Everyone, welcome back. I know I haven't been here in a while, but I'm back now and let's suffer together and do another lead code problem. So today we are going to be working with subset 78 and we are given an integer array nums of unique elements and we have to return all possible subsets. So a subset is basically a Subset is basically something like this. So we are given our array of nums, and then we basically have to return a combination of possible presence of a particular element in the subset, right? So for 1, 2, 3, we can choose to not include any of the elements, and that would be the empty set, or we can choose to have 1, 2, or 3 by themselves, or we can have 1 and 2 together, 2 and 3 together, 1 and 3 together, and all of them at the same time. So on average, given n, we shall have 2's power n subsets. And so that also gives us the hint to our complexity for this particular task today, because we have to generate all these possible subsets. So that means our complexity is going to be 2's power n times n times n. Why? Because we're also processing this particular nums, right? So 2's 10 comes from here, n comes from processing the nums array. So this is going to be our complexity. And yeah, so once we have that, now let's think about how can we solve this problem, right? If I am starting it by myself, then I will think about obviously backtracking. Like normally, how we do this is like this. So I have these particular elements, and I can either choose to have a particular element in the current subset or not. So, right. So for 1, I can have 1 or phi. I don't have phi here, but let's just call it phi. Phi means an empty set, right? So I can, these are my two options. For 2, the options are phi and this is, again, 3 and 5. And so basically I can do this and I can kind of build a tree. So starting from the first element, I have these two. Then my second options are going to be for each of them. So for each of these two options, I have these two further options, right? And from here, so this is x4, and then here I'll have phi's again. So basically, it's going to look like a recursive DFS. And what I can do over here is basically use the same exact thing for my building of tree, I guess, building of results. So yeah, so let's get started here. Starting here, I'm going to have a res. This is going to be the resultant subarray. And then I'm going to have a DFS, as we just talked about, to kind of go through our solution. So I'm going to pass in the current index to the DFS, and then we're going to have two choices. The first is add the subset to the, so add the subset to the result. While building the subsets, we are going to have two options: include I or not I, right? So the first one is, I'm going to also define another subset here. And because subsets are mutable, so what I'm going to do is, if I want to include the I will basically do DFS I plus 1, right? And the subset here would be subset dot append is going to be, it is going to be nums of I, right? So Yes. So include I, don't include I. So if we don't include I, then obviously it's going to be this DFSI. So now this will basically help us build our result subset, or like the subset. Now, what we need as an output is an array of all possible subsets, right? And how do I decide when a subset is done? And I want to add it. So that is going to be done here for our base condition. Base condition is going to be if I is greater than or equal to length of nums. In that case, what I want to do is I'm going to res.append subsets copy. Why? Because subset is an array and it is mutable, and we don't want to run into those challenges. And then, yeah, so then return, that's it. And we can call our function by DFSing on the 0th index, and that should be it. Let's try running it. Oh my God, I did not log in. See, this is how I know I haven't been here in a minute. All right. All right, I think I have logged in now. So let's refresh. And I'm in, and let's run. Oh, sorry. I shouldn't be returning DFS.0. I should be returning res. It doesn't seem like that it's doing anything. Yeah. Okay, so I is going to be. Oh, wait, what? What did happen? Okay, I think my call to DFS is not processing. And okay, let's do another call. Okay, so 132. Okay, seems like there is an issue. I think my backtracking isn't working properly, so let's do it. Subset dot pop. Okay, looks good, looks good. And let's try submitting it. All right, and the runtime is great, memory is great, so I guess memory is going to be obviously the time and space complexity are both n times 2's power n, both complexities. And yeah, we can just double check as well. Right, thank you. Bye.